All right, let's dive right in. Today, we're talking about a massive, almost invisible shift happening deep inside the tech that powers our entire AI world. It's a story about manufacturing, it's about supply chains, and, believe it or not, how a simple change in shape is about to redefine the future.
So let me ask you this. What if the one thing holding back the next generation of AI, the thing causing these insane bottlenecks and driving prices through the roof, wasn't some super complex algorithm, but was just a shape?
And that shape is the circle. You see, for decades, every single advanced computer chip we've ever made has started its life as a slice of a perfect, round silicon wafer. It's been the literal foundation of our digital age. But that foundation is starting to crack, big time.
Okay, so that brings us to our first big idea here, the circle problem. We're going to break down exactly why this elegant traditional shape has suddenly become a massive, and I mean massive, roadblock for the future of computing.
The problem is really just simple geometry, right? Our most powerful AI chips are rectangles. But when you try to cut a bunch of rectangles out of a round disk, you're always left with a ton of unusable material around the edges. Just think about trying to make square cookies from a round sheet of dough. All those leftover scraps? In this case, that's incredibly expensive, hyper-pure silicon is just getting thrown away.
And all that waste is at the very heart of what the industry is calling the CoWoS bottleneck. This is the critical process that builds our current AI systems, and let me tell you, it is hitting a wall and it's hitting it hard.
So what on earth is CoWoS? Well, it stands for Chip-on-Wafer-on-Substrate. It's this brilliant piece of tech from TSMC, the world's top chip maker, that lets them stitch together multiple chips and super-fast memory onto a single slice of silicon. This is the magic that made things like Nvidia's H100 possible. It is literally the engine of the AI boom we're in right now. But it's an engine that runs on those inefficient round wafers. And wow, this chart just lays the problem bare. When you use the CoWoS process for today's huge AI modules, you're only getting about 60% utilization out of that wafer. Let that sink in for a second. For every single incredibly expensive silicon wafer that runs through the factory, nearly 40% of it is just tossed, gone.
So you can imagine what happens next, right? You've got this insane inefficiency crashing head-on with an explosive demand for AI, and boom, you get a global choke point. There's just not enough to go around. Nvidia is so dominant right now that it is reportedly locked down over 60% of all of TSMC's CoWoS capacity, leaving every other AI company on the planet fighting for the scraps. But what if you could just get rid of the circle altogether? What if you could break free? Well, that leads us to the solution, what we're calling the rectangular revolution. The answer is a technology called CoPoS. That's Chip-on-Panel-on-Substrate. Instead of a round wafer, you build the chips on a large rectangular panel, kind of like the ones used to make flat panel TVs. Now, this isn't just a minor upgrade. It's a complete reimagining of the manufacturing canvas, one that just shatters the physical limits of the circle.
And get this isn't some far-off science fiction fantasy. The roadmap is already in place. TSMC is set to kick off pilot production in 2026, then ramp up to huge 515mm panels for mass production by 2028, and it's only going to get bigger from there. The scale is set to ramp up incredibly fast.
I mean, just look at the comparison here. It is night and day. With CoWoS, you're stuck on that round wafer, you've got that lousy 60% utilization, and there are hard limits on how big your chip package can be. With CoPoS, you jump to a massive rectangular panel. Your utilization skyrockets to over 95%, and you basically have a near limitless canvas for designing these monster AI systems. The waste is practically gone.
So, this revolutionary tech is coming. The billion-dollar question is, who gets to use it first? And that, my friends, brings us to Nvidia, and what some insiders are calling the Feynman singularity.
It looks like Nvidia has managed to lock in what you could call an iron triangle for its 2028 GPU, which is codenamed Feynman. It's a combination of three critical advantages. First, their own advanced chip design. Second, TSMC's brand new A16 manufacturing process. And third, this is the real kicker, exclusive early access to CoPoS packaging. It's a trifecta that could be absolutely unbeatable.
And there is this incredible synergy here. That new A16 process has a secret weapon called backside power delivery. What that means is they move all the power lines to the bottom of the chip, which frees up the entire top surface for nothing but data. It creates this perfectly clean, uncluttered canvas for CoPoS to connect a massive cluster of chips together with the density and efficiency we've just never seen before.
So let's put some hard numbers on this, because this is where it gets really crazy. First up, scale. A single 600mm rectangular panel has over 5 times the surface area of one of today's round wafers. That alone is a monumental leap in manufacturing throughput.
But it's not just bigger, it is so much smarter. Because you're putting rectangles on a rectangle, that usable area jumps from a wasteful 60% to an incredibly efficient 95% or more. The economic hemorrhage from all that wasted silicon is effectively stopped.
And here it is, the bottom line. Industry estimates suggest CoPoS could reduce the total cost of making a finished AI module by 20 to 30%. That's not a small improvement. That fundamentally bends the entire cost curve of AI, making it cheaper to build and deploy the most powerful systems on the planet.
So if Nvidia has exclusive access to this game-changing, cost-bending technology, what happens to everybody else? Well, this is what we're calling the competitor's squeeze. Yeah, for competitors like AMD and Google, this creates a really risky path forward. They're left dealing with the same old CoWoS bottleneck, which forces them to gamble on other suppliers like Samsung or Intel, whose alternative technologies are either less mature or have had historical issues with yields. It's a high-stakes bet that could leave them a full generation behind before the race even really starts.
This table really lays it all out. You see Nvidia moving from the mature CoWoS to the revolutionary CoPoS, both safely at TSMC. Meanwhile, Google is rumored to be exploring Intel's EMIB, and AMD is looking at a company called PowerTech. Now, these are all viable technologies, but they represent a huge strategic gamble, a move away from the industry's most stable and advanced manufacturer.
So let's bring this all home. The implications here go far, far beyond just chip manufacturing. It seems pretty clear that the future is rectangular.
Because, look, this is about more than just making cheaper, more powerful chips. When you secure a multi-year lead in the fundamental manufacturing process, that is how a company cements its dominance. It's how you gain control over the economic and, frankly, the geopolitical levers of the entire AI industry for the next decade.
And so it all comes back to that simple shape we started with. The future of AI isn't just going to be written in code. It's going to be determined by geometry. The winner of the next decade will be the first to escape the tyranny of the circle. The only question left is, who's going to be left behind? Thanks for tuning in.